If you're studying GCSE Higher Maths or beyond, you'll come across quadratic equations throughout your studies. A quadratic equation will have the highest power of the unknown variable as a squared term. An example might be x squared is equal to 49, or p squared minus 2p is equal to 0. These are all quadratic equations. Before, we've solved linear equations, so a linear equation has the highest power of 1. So 2x plus 4 is equal to 8. The x term has now a power of 1. In the video, we're going to look at a range of different quadratic equations and the ways in which we can solve them. Let's start off with the easiest type. The easiest type are where we have x squared is equal to a, where a is a constant or some number. So for example, we might have x squared is equal to 49. What we're going to do is look at solving this. The easiest way to deal with this is to square root both sides. What we do to one side, we must do to the other. So if I square root both sides, I'm going to have x is equal to plus or minus the square root of 49. And that's going to give me x is equal to plus or minus 7. So I can simply go ahead and take the square root of both sides. We get a positive and negative answer here. If I square minus 7, I'm going to get 49. If I square positive 7, I'm going to get 49. So if we look now, a nice graph to draw this would be, or represent this would be drawing a graph of y is equal to x squared. This is what we call a parabola, and it will look something like so. Let's just tidy that up and make it look symmetric. So it will be symmetric about the y-axis. So if I do that, this is something roughly what it looks like. Y is equal to x squared. So for example, if I took now my value here, this is minus 7, it's going to give us a value of 49. If I took positive 7, it's going to give me a value of 49. Therefore, when we take the square root, we will get now plus or minus answer. Another example of this, slightly harder, would be 2x squared is equal to 72. We would divide both sides by 2, x squared is equal to 36, and then take the square root of both sides, x would be equal to plus or minus the square root of 36, which is 6. So we're going to have now a maximum of 2 real solutions. Throughout the video, I'm going to focus on GCSE, so all the solutions will be what we call real. Okay, let's now look at the next type. The next type are when we have ax squared plus bx is equal to 0, or something along these lines. So for example, we might have x squared plus 4x is equal to 0. And we're going to go ahead and look at a method to solve this quadratic equation. I can't just go ahead and square root both sides, so what I'm going to do is factor this. I can see I've got a common factor of x in both of these terms. So if I factor that, I'm going to have x, then I'm going to have x plus 4 is equal to 0. When solving quadratics of this type, we want the right-hand side to be equal to 0. So in this case, we've just simply square rooted both sides. In this particular case, we want the right-hand side to be equal to 0. Now, this number multiplied by this one is equal to 0. That tells me now that either x is equal to 0 or x plus 4 is equal to 0. One or both of these has to be now 0 for this to be true. So if x is equal to 0, we can just write that out. Or if x plus 4 is equal to 0, then x will be equal to minus 4. So we've got 2 possible solutions to this quadratic. We've got x is 0 or x is minus 4. The next ones that we're going to look at are of the form ax squared plus bx plus c is equal to 0. And we're going to look at factoring this type. So right here, we've got ax squared plus bx is equal to 0. Now we have a constant. And the way we do this is to set up double brackets. Again, we want the right-hand side to be equal to 0. We look for 2 numbers that multiply to give the c term and add to give the b. So let's start off with some. Let's have a look at x squared plus 10x, and then we're going to have plus 16 is equal to 0. I want two numbers that multiply to give 16 and the same two numbers that add to give positive 10. That's going to be 8 and 2. So I'm going to get x plus 8 and x plus 2. I simply put these now in brackets like so. So this now is factoring the form ax squared plus bx plus c is equal to 0. Now, if you're unsure and you don't know that you've got that right, let's expand this out. So we would have now x times by x, which is x squared. We would have x multiplied by positive 2, which would be plus 2x. We would have now the 8 multiplied by the x, so that's plus 8x. And then 8, positive 8 by positive 2 will give me plus 16. And that would be equal to 0. And we can see that's x squared plus 10x plus 16. So all we need to do now is consider that one or both of these brackets are equal to 0. So if x plus 8 is equal to 0, then x would be equal to minus 8. Or if x plus 2 is equal to 0, then x is equal to minus 2. Now, in this particular case, we get about x plus 2 and x plus 8. That doesn't matter. What we need to consider are other types. So, for example, we might have x squared minus x minus 6 is equal to 0. So, if we look at this one, we can factor it. We're looking for two numbers that give minus 6 and add to give minus 1. This is in the correct form. This is in the form ax squared, so here's my x squared term, plus bx, so here's my x term, plus c is equal to 0. So let's go ahead and factor that. Two numbers that multiply to give minus 6 and add to give minus 1, we can have x plus 2 and then x minus 3. And that's equal to 0. If you were unsure, just go down 1 times 6, 2 times 3, nothing else is going to give me 6, okay, or minus 6. So we can see we need two numbers now that are going to give me this minus here. So from here we can see x is going to be equal to minus 2, or x is going to be equal to positive 3. If x plus 2 is 0, x is minus 2. If x minus 3 is 0, x is 3. And we need to be very careful. One common error here is to put in those brackets x minus 2 and x plus 3. That would not work, as when we expanded them out, we would get plus x. So if you want to check you've got your factors correct, just go ahead and do it. Sometimes it won't be that straightforward. We might have x squared minus x is equal to 42. This time, again, we need to get the right-hand side to be 0, so we can write this as x squared minus x minus 42 is equal to 0. This is of the form ax squared plus bx plus c is equal to 0, so we factor and solve using double brackets. We look for two numbers that multiply to give minus 42 and add to give minus 1. X plus 6, x minus 7 is equal to 0, so x would be minus 6 or x would be equal to 7. So these are quadratic equations that factor. These are the first three types we are going to look at. Quadratic equations rarely fall into this type, and we need to use alternative methods to solve them. Later on in the video we're going to look at using the quadratic equation or completing the square to solve. So these are your first type. If you just got x squared is equal to some value, a numeric value or a constant, square root both sides. An alternative to this one is factoring as a difference of squares, and we'll look at that as we go. If we have ax squared plus bx, so we have no constant, and when we say constant, constant is a value without an x. We can factor like so. So for example, if I did, let's say 2x squared plus 6x is equal to 0, we could take a common factor of 2x out, and that would leave me x plus 3, and that's equal to 0. So if 2x is equal to 0, then x would be equal to 0, or if x plus 3 is equal to 0, x is equal to minus 3. And we can use this method of a single bracket when we have no constant. If we got a constant, we'll go ahead and try and factor it. It won't always factor, but we'll try and put it in a set of double brackets and solve. So let's go ahead and look at some of these. We're asked to solve the following quadratic equations. And what I've done here is just a little flowchart. Can we square root both sides? If the answer is yes, we'll go ahead and do it. If not, we can try and factor it. They won't always factor. If they don't, we're either going to use a quadratic equation or complete the square. So we're going to go for a few of these. So let's start off here. Okay, we'll take this one to begin with. X squared minus 9 is equal to 0. So what we can do is write this now as x squared is equal to 9 by adding 9 to both sides. Taking the square root, x will be equal to plus or minus the square root of 9, and then x will be equal to plus or minus 3. Sometimes you'll be asked to factor this as a difference of squares. If we wanted to factor this as a difference of squares, we could write this as x plus 3 and x minus 3 is equal to 0. For difference of squares, 9 is a square number and 1 is a square number, and we can see this is a difference of squares. This is also a difference of squares, so we could factor this as x plus 7, x minus 7. If we just consider this, we're not asked to, I would use this method, but you can factor it. When you expand this out, we would have x squared minus 3x plus 3x minus 9 is equal to 0, and we can see that these will cancel out. Plus 3x and minus 3x will cancel out. So, can I square root both sides on this? Yes, I can, so I'm going to use that method. With all of these three in the middle, we can do that with all of them. So that's the method I choose. I'd add 49 to both sides, and then I would square root both sides. This one right here, what I would do, I could factor that as a difference of squares. Alternatively, starting with 9x squared is equal to 64. I could divide both sides by 9. X squared is equal to 64 over 9, and take the square root of both sides. X would be equal to plus or minus the square root of 64 over 9. The square root of 64 is 8, the square root of 9 is 3, so x would be equal to plus or minus 8 over 3. And again, if you wanted, you could factor that as a difference of squares. So that's the first type. Can we square root both sides? Yes, we can. We go ahead and do that. Okay, let's now look at a different type. These are of the form ax squared plus bx is equal to 0. So we've got no constant term. This is a constant, this is a constant. The constant is the term that has no x. So let's look ahead, go ahead and factor this one. Common factor of x. So I could do this one as x plus 6 is equal to 0. One of these or both have to be equal to 0, as if we multiply any number by 0, we're going to get 0. So I've got the right hand side now to 0, and we're going to say that x would be equal to 0, or x would be equal to minus 6. If x plus 6 is 0, then x is minus 6. Let's look at this one right here. We can take a common factor of x out. So we'd have 3x squared minus 4x is equal to 0. So x is a common factor. That leaves me 3x minus 4. So we can see now that x would be equal to 0. Or 3x minus 4 is equal to 0. And if we went ahead and solved that, we would add 4 to both sides and divide by 3. So x would be 4/3. What else have we got? This one right here, again, we would simply take the x out. So this is the first way we can factor with a single bracket, as we have no constant. So with this one, we couldn't square root them, but we could factor it the first way. Okay, let's go on and look at some others. The first ones, now we have a constant. These in the form x squared plus bx plus c is equal to 0. All of these are. So let's go ahead and look at these. We can't square root both sides. We can't do the first factoring, but we can do the second factoring. So let's take this one. We need two numbers that multiply to give minus 15 and add to give minus 2. That's going to be minus 5 and plus 3. So we could say that this is going to be x minus 5, and then we're going to have x plus 3, and that's equal to 0. If you want, you can go down a list. 1 times by 15, 3 times by 5, they're my only choices. So this is in the correct order. Do make sure that you've got your x squared, x and constant. If these are the other way around, just swap them. So I've looked at two numbers that are multiplied to give minus 15, and you need to be careful, and add to give minus 2. If this had been plus 2, these values would have been the other way around. It would have been x plus 5 and x minus 3. Again, if you're unsure, multiply that out. So now we can see x minus 5 is equal to 0, or x plus 3 is equal to 0. So x is equal to 5, or x is equal to minus 3. So they're the two possible solutions of the quadratic equation. This one right here, two numbers that multiply to give minus 12 and add to give positive 4. That's going to be x plus 6 and then x minus 2, and that's equal to 0. So x is equal to minus 6, or x is equal to 2. So these are solving now the quadratic equations in the form ax squared plus bx plus c is equal to 0, and they need to be in this form. If they're not, rearrange them in that form. So far, when we've looked at this form, ax squared plus bx plus c is equal to 0, we've had a coefficient of 1. The coefficient of 1 has been in front of the x squared term. So x squared, x squared, x squared, x squared. On these particular examples, we have a coefficient now that isn't 1. So 2x squared, 2x squared, 3x squared, 4x squared, 2x squared and 2x squared. I've done quite a lengthy video on this, so if you want to watch that on the method I use, you're welcome to do so. We can still factor these, and I'm going to show you a quick method of doing that, and the main focus of this particular method will be in the other video. So this is my method to do it, and what we'll do, we'll take, which one? Let's go for this one. We've got 2x squared this time, plus 5x minus 12 is equal to 0. This is in the form ax squared plus bx plus c is equal to 0. So we can see in this particular case now, a is equal to positive 2, b is equal to positive 5, and c is equal to minus 12. What we do with this, again, is set up two brackets. And this is a slightly, it's not mathematically rigorous, but it's quite a nice way of doing it. What we're going to do is simply put 2x in both brackets. We're now going to multiply a by c. 2 times minus 12 is minus 24. We're looking for two numbers that give minus 24 when multiplied and add to give positive 5. So we want two numbers that multiply to give minus 24 and add to give 5. That's going to be plus 8 and minus 3. I'm going to put these in, plus 8 and minus 3. Now, at this stage, we can take any common factors out. So I can take a common factor of 2 out of this one. And then I've got x plus 4 and then 2x minus 3. Can't take anything out from there. We can divide the equation by 2. So just simply now write in that x plus 4, then 2x minus 3 is equal to 0. So x would be equal to minus 4, or x would be equal to, adding 3 to both sides and dividing by 2, 3 over 2, or 1.5. So all I've done in this case is simply put 2x in both brackets. I've multiplied the 2 by the minus 12 to get minus 24, and said to myself, what two numbers multiply to give minus 24 and add to give 5? Plus 8 minus 3, put them in the brackets, factored them and solved. This is seen to be a harder skill. Let's have a go with this one. We've got now double brackets. That looks like it's going to factor. We've got 3x, and then we'll have another 3x, and then we'll close the bracket off and set it to 0. A times by the c. This is in the correct form. This is in the form ax squared plus bx plus c. 3 times by 4 is 12. We need two numbers that multiply to give positive 12 and add to give minus 7. That's going to be minus 3 and minus 4. If I multiply a minus by a minus, I get a positive. If I add the two minuses, I'm going to get minus. Taking a common factor out, we're going to have 3x minus 1, 3x minus 4, and that's equal to 0. So dividing both sides of the equation by 3, we're going to get x minus 1, 3x minus 4 is equal to 0. So x minus 1 is 0, that means x would be 1, or now 3x minus 4 is equal to 0, add the 4, divide by 3, 4/3. And if you like, you can check those. So far, all of these have factored. We couldn't square root both sides, so we factored it. So that now is solving quadratic equations that can either be square rooted or factored. Now, these don't always factor or square root. So what we need to do is look at an alternative method. And the first method you'll come across is the quadratic equation. If we have a quadratic equation in the form x squared plus bx plus c is equal to 0, then the solutions are x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. This is a quadratic equation. You will get this in any exam book that you're doing. So if you go through a quadratic equation and you can't square root both sides, you try and factor it. If it won't factor, we either use a quadratic equation or complete the square. We're now going to look at using the quadratic equation. So let's go ahead. We're asked to use the quadratic equation formula to find the solutions where they exist of each of the following equations. Now, where it says where they exist, this is talking about real solutions. As you go later on in your studies, you will look at the complex roots or imaginary roots of quadratic equations. For now, when we say real numbers, these are the numbers you and I know. So 5, 2.7, minus 3.8, they're not imaginary numbers. Okay, so let's first look at this. The first thing that we're trying to do is factor it. So if we look at this one right here, we've got the 4 times by the 3. This is the one now that, let's see what we're going to get. We're going to get 4 times by 3. This will factor. We'll factor it first and then go ahead. So 4 times by 3. So let's put in brackets. Let's see if this will factor. So first thing to do, down your list. Does it square root? No. Let's see if it factors. We'll go ahead and see if it factors. So 4x, and that's going to be equal to 0. So 4 times by 3 is going to give me the 12. So let's see, we need 2 numbers that multiply to give 12 and then add to give minus 7. So that's going to be the minus 4 and the minus 3 again. So this looks like it's going to factor. So we're going to have x minus 1, simply taking a common factor, 4 out, and then 4x minus 3 is equal to 0. So we can see that x is 1, or x is going to be 4x minus 3, or x would be 3/4. So that does factor. Let's pretend now that it didn't factor, or we couldn't see that it factored. If we can't factor it, what we're going to do is go ahead and use the quadratic equation. So let's use the quadratic equation on this. We need this in the form ax squared plus bx plus c is equal to 0. So if the right hand side is not 0, bring everything to the left hand side. So let's look at now the value of a. The value of a is positive 4. A is positive 4. We need to consider the sign. B is going to be equal to minus 7 and c is going to be equal to positive 3. It sends me nuts when people say that the b term is 7. It's not, it's minus 7. Minus 5 plus 17 plus 8 minus 5. You need to take the sign in. The c term plus 3 minus 7 minus 9. If the 9 was over here, we would need to bring it over and set now the equation to 0. So the quadratic equation, x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So what we're going to do is sub this in. Now with this particular one, it's going to work out okay. What I'm going to do is show you how to set this up on a Casio calculator, and you can just simply plug the numbers in. What we do, we hit the fraction. Then we put in now negative. So you can either use that one or this one. Technically it's this one you should use. Then we put now our brackets. We'll start with the positive. We're going to do a plus or minus, but we'll start with the positive. Then we're going to square b. Now if b is negative, when I square minus 7, I'm going to get to positive 49. Another killer mistake is to put minus 49. Minus 4 times by 8, so I'm going to feed a in there, times by c, and I'm going to feed c in there. All over 2 lots of a. So all I'm going to do is go through this and pick up my values and put them in. So we know that b is minus 7. So minus 7, so in goes the 7. Plus the square root of now minus 7 squared. So all I'm doing is plugging this in. Here is b, and I'm putting that in. Minus 4 times by a is 4, times by c, which is 3. So that goes in there, all over 2 lots of a. So 2 lots of a is going to be 2 lots of 4. And I hit that, and there we go. That's the first solution. We can see what we got that anyway. What I now do to get my next one is substitute, or make the substitution for the plus. I take the minus, and this will give us the other one. And hopefully we'll get 3/4. And there it is. So that's using the quadratic equation. Set it up on the Casio, and we've got our solutions. You must show in your workings that you're putting all these values in. So there we go, using the quadratic equation. Let's have a go at another one. We can choose one of these. That looks like it's going to factor as well. We'll go ahead and try and factor this one. So it's in the correct form, x squared plus bx plus c is equal to 0. So 2 times by minus 10 is minus 20. So let's put the 2x in each. I'm not suggesting that you have to use this method. It's mathematically incorrect to some extent, but it can help you factor these. So we need two numbers that multiply to give minus 20. I'm doing 2 times minus 10. That's a times c, that add to give 1. That's going to be plus 5. And then we're going to, and I'll write it the other way around just to make the cancelling slightly better. It's going to be plus 5 and minus 4. So plus 5 and minus 4. So let's put in minus 4 and plus 5. So we can take out a common factor of 2. So we're going to get x minus 2. And then we're going to get 2x plus 5. And that's equal to 0. So we can see now, dividing both sides by the 2, x minus 2 is 0. So x would be equal to 2. Or 2x plus 5 is 0. Which means that x would be minus 5 over 2. So let's go ahead and see if that works. So what we've got then is the following. A will be positive 2, B will be positive 1, and C will be minus 10. So quadratic equation, our solutions, x will be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Again, over time you'll just memorise this, but you don't have to. It will be given. So let's grab up this. And the reason I'm using these now is because we can see that they factor. Using the quadratic equation is a case, we would use it when we can't factor them. So this one here we couldn't factor. We don't know two numbers that multiply to give minus 10 and add to give now positive 2. 1 times 10 doesn't work. 2 times 5 doesn't work. So we would have to use either the quadratic equation or completing the square. So, and we will look at completing the square shortly. So what we're going to have then is minus, and I'll just set this up again. So minus b plus or minus, and you will put the numbers straight in. I'm just putting the generic formula back in to show you, and we'll go back through. Minus 4 times by a. And the good thing about this is if you set it up, then you can do a whole host of these equations and write them in. So minus b, so that's going to be minus 1. Then we're going to have plus or minus for square root, and I've taken the positive to begin with. B has gone in again. Then we're going to put in 2 for a, so there's my a, and then I'm going to put in now, and you must put in minus 10. So minus 10, and we will now put this over 2 lots of a, 2 lots of 2, and we should get the same solutions as we did for factoring it. So there's 2, good. Switch this over to the negative. Press delete, we minus that, and then there's minus 5 over 2. So there we go. Now let's have a look at this when we don't have these nice numbers. So when we don't have one that factors, and that's where we use the quadratic equation or completing the square. It's when they don't factor. So I said that this one doesn't factor, and we'll use the quadratic equation. So what we'll have then is x squared. So in this particular case, I'm taking this one here. A is going to be equal to 1. B is going to be equal to positive 2, and C will be equal to minus 10. So we tried to factor it. We can't find two numbers that multiply to give minus 10 and add to give 2. So we're going to use the quadratic equation. So x will be equal to minus b. So that's going to be minus 2 plus or minus, and we'll take now the positive in the calculator first, the square root of b squared, which is 2 squared, minus 4 lots of a, which is 1, multiplied by c, which is minus 10. And all of this now is over 2a, which is 2 lots of 1. So I'm simply feeding in with the correct signs. Make sure this is going in as minus 10. Otherwise, you're going to be in a bit of trouble, as you're going to try and take the square root of a negative number, which will say math error on the calculator, and that's where we're talking about now the solutions that are not real. That means that they're either complex or imaginary, and we don't study that at GCSE. So let's go ahead. Let's just put this in. So we can have minus 2 plus the square root of 2 squared. So just plug in all of this in. Minus now 4 lots of a, which is going to be 1, multiplied now by negative 10, all over 2 lots of 1, which is going to give us 2 lots of 1, which is just there. And now this gives us, this is what we call the exact answer. So this is a third, and we would say that the solutions are minus 1 plus root 11 or minus 1 minus root 11. We're asked to give these to 2 decimal places. So 2.32, so let's write that in. X is equal to 2.32, or we need to consider the other solution. The quadratic will have a maximum of 2 real solutions. So to swap it over, we will now look at the negative, and we get the minus 1 minus root 11, which is minus 4.32. So minus 4.32. So there are 2 solutions to the quadratic equation. So that's using the quadratic equation. Can we square root both sides? Very rarely it'll happen. No. Can we factor it? If we can factor it, factoring it is easier. If we can't, we're going to use either the quadratic equation or completing the square. Now I'm going to do basic completing the square, and this is now another method which you'll use potentially to solve a quadratic equation. And I'm going to take this one. And the reason I'm using this one is generally at GCSE you will only have an x squared value, the coefficient, to be 1. If you've got it of something else, then we can deal with this, and I've done videos on it, but essentially at GCSE you'll only generally, and I say generally, be asked to now solve equations or complete the square when we've got a coefficient of 1. What we do, we write it in this form right here. We've got x squared plus x and then the constant. So this is in the form ax squared plus bx plus c is equal to 0. And I've done lots of videos. So if you want to search it, because I'm not going to spend too long on this, look at completing the square. We take half the coefficient on the x term inside a set of brackets with an x. So I've got x plus 1. That's half of 2. I now square this bracket and substitute this number away, which is minus 1. I substitute the existing 10 and we set this equal to 0. So I take half the coefficient, I square this out, subtract this number away squared, and then keep the minus 10. So what we now do is add the 11 to both sides. So I've got x plus 1 all squared is equal to 11. Taking the square root of both sides, x plus 1 will be equal to plus or minus the square root of 11. Subtracting 1 from both sides, x is equal to minus 1 plus or minus the square root of 11. And that is now the exact answer that you saw on the calculator. Minus 1 minus root 11, and then we had now minus 1 plus root 11. And that's what we've got. And that's called completing the square. I'm not going to spend too long on this, as there are multiple tutorials on this. But this is another way of solving a quadratic equation when we can't factor it. So if we look at this one now, we've got x squared minus 6x minus 5 is equal to 0. Can we find 2 numbers that multiply to give minus 5 that add to give minus 6? So we could try 1 times by 5. That's not going to work, as 1 will need to be positive and the other will be negative, so we can't factor this. So I'm going to complete the square to solve. So x minus half the coefficient, so x minus 3, all squared. We now need to subtract away this number squared, which is minus 9. I've got the existing minus 5, and that's equal to 0. So adding now the 14 to both sides, x minus 3 all squared is equal to 14. Taking the square root of both sides, x minus 3 will be equal to plus or minus the square root of 14. And then we can see x would be equal to 3 by adding the 3 to both sides, plus or minus the square root of 14. So we could find now this to two decimal places if we wanted. So 3 plus the square root of 14, and that would give us now the 6.74, and then if we went the other way and did minus now the root 14, we would end up with minus 0.74. Now, that is one method. You could, of course, use the quadratic equation with the value of a being 1, the value of b being now minus 6, and the value of c being minus 5. So if we set this up with the quadratic equation, we could simply plug it in. So we'd have minus b, which is minus 6, and then we're going to have plus the square root of b squared, and that's minus 6 squared, which will give us a positive, minus 4 times by a, which is 1, times by c, which is minus 5, all over now 2 lots of a, which is 2 lots of 1. And that will give me now 3 plus root 14, which is what we had, and then 3 minus root 14, which is what we had, and they are the decimal answers. So this is what we call an exact answer, and that's our decimal answer. We can actually derive the quadratic equation, the x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a, by completing the square on this term. And again, in another video I've done that, but it's beyond the scope. So, bit of revision. Solving quadratic equations. A quadratic equation will have the highest power of x, or the unknown variable, as a square term. So you might have x squared plus x minus 8, that's quadratic. This is quadratic. Our first task is now, can we square root both sides? Very rarely we can do that. We've got a couple of methods of factoring. So if we have x squared plus bx is equal to 0, we've got one method with a single bracket. If we've got x squared plus bx plus c is equal to 0, where we have constant, we have double brackets. If we can't factor them, then we use either the quadratic equation or completing the square. So there we go. A bit of brief revision on solving quadratics throughout GCSE.